Welcome, everyone. I'm going to start now. I'm Mano Kovacs. I work for Cloudera, and I'm going to have a talk about Solr consistency and recovery internals. Yes? Oh, okay. I don't think I have control over the volume. Is it better now? Okay, I'm trying to talk louder then. If you don't hear me, just raise the roof, and I'm trying to do my best. Okay, so when I say Solr, I mean SolrCloud in this case. So every time I'm referring to Solr, I'm always thinking about SolrCloud. So about me, I work for Cloudera as a search engineer, and one of my job is to answer questions that starts like, where my Solr went, what happened, why it's not working, why it's not coming up. And well, when we get these questions, usually it's not easy to answer. So it's usually digging the code, digging the log files and find it. I was supposed to have a co-presenter, Mike Drob, who is actually the co-author of this talk, and actually was mentoring me when I started at Cloudera Search, but he lives in Houston, and he's a Harvey victim, so he couldn't be here today. So I'm going to talk today about these points. First, I'm going to start by have a brief introduction about the SolrCloud architecture, how it works, how it have the consistency, the durability. Then I'm going to talk a little about the leader election, how that goes in Solr. And then we're going to see which are the cases that can trigger recovery when we need the recovery in the system. I'm going to explain in more or less details how this recovery goes in Solr. And we're also going to take a look at two special features Solr has for consistency. But for start, I would like to know how much experience you guys have with Solr and the recovery. So, who is like managing Solr clusters? Who is responsible for handling? Great. How many of you have ever had to dig into the log files to figure out what's going on? Even more. It's interesting. And how many of you took the time and go to check the source code to see why it happened? It's still a very high number. Okay, so I'm trying to be as detailed as possible, just to give you a better picture. So, as many of you may know, Solr uses collections as a logical grouping of homogeneous data. So you put, it's similar to a database table. You put the documents into a collection. In SolrCloud, the collection can be split up into shards, and the shard key is responsible to, well, not the shard key, the shard routing key is responsible for deciding where the document goes in which shard. Shards are good because you can place them in different nodes. That helps you scale out your cluster into splits. And these shards can have multiple replicas, so it can be replicated. And among these replicas, each shard has several replicas, and the replicas among one shard has one leader. It is important because the write always goes through the leader. Even you are sending an update into any replica of the shard, it will be routed to the leader of the shard, and it gets written to the index. However, but you can query any of the replicas because they are going to have more or less the same data as the leader, since the replication is near real time. So basically, our first step to solve this construct is to have a leader among the replicas. So how do we get there? There is a process called leader election. Solr built on Zookeeper, SolrCloud built on Zookeeper. Zookeeper is a distributed registry, a central service there where you can store small amount of data. Plus, Zookeeper gives us a lot of feature for distributed synchronization, which it is important if multiple nodes want to do the same stuff, and one should only succeed. So there is a Zookeeper recipe called the leader direction recipe, which goes that the node or the clients who wants to become the leader register a node, a file into this registry, into a list. And these nodes are called ephemeral and sequential nodes. Ephemeral means that these nodes are only exist in Zookeeper until the client is connected. So the client is disconnecting. For example, if the leader goes down, it crashes or something, this node is being removed by Zookeeper. It says that the client created a disconnect, so it deletes it right away. The sequential part is that every new file gets a unique sequence ID, which is strictly increasing, and it's kept by the Zookeeper. So this is a very convenient feature from Zookeeper for us to have a leader election, since all the replicas that want to become the leader are going to register a node, and the first one is going to be the leader, obviously, from these nodes. And if that leader goes down, the second become the leader. For that, each replica who didn't become the leader is going to watch the previous one, since if the previous disconnects, then he might be the new leader. Now, if a replica wins the leader election, it doesn't right away becomes the leader. It becomes more like a leader candidate. And after becoming the candidate of the leader, it starts a preparation process with several steps to ensure that he can be the leader. He's the right candidate for the leader. So what it does, in case it's a restart, that all replicas probably were restarted, or just that node restarted, and some reason it got to be the leader candidate, it waits for the other leaders to come up to participate in the leader election. Obviously, they won't win the leader election since our replica just won it, but it's going to wait for them because one of the other replicas might be the ex-leader, the previous leader, and in some cases it can have some updates that this replica, the new leader, didn't get. So it's going to wait 3 minutes. I think you can configure that, but by default it waits 3 minutes until all the replicas come up. And then it says to all the replicas, the leader candidate, ask all the replicas to sing to me all the updates you have that what I don't have. This way, if there was an update coming in before the restart to the previous leader that didn't get replicated because our new leader was just, I don't know, shutting down faster, then we can have that. We won't lose any updates before the restart. If it's not a restart, if the previous leader somehow crashed and our replica is becoming the new leader, it checks if it was active before. It is important because it can happen that our new candidate just came back from a long crash. So it was, I don't know, there was a memory issue and it was fixed. And when it comes back, our previous leader just crashes as well. So at that moment, he might be way behind with the replication. He might have a lot of updates missing. And we don't want that replica to take the new leadership because he's not going to have the latest data, and all the other replicas are going to copy that stale data. And this is a good defensive mechanism, but it can lead us to a very unpleasant situation where, for example, if we lose connection to Zookeeper crashes or for some reason, all the replicas are going to believe that they are down. And when they come back and they connect to Zookeeper, they're not going to participate in the leader election because they're going to believe that they are down and they're behind, and manual intervention required to get this back. There is a Jira, well, actually a long ascending Jira in the Solr project resolving that, but I think even today the latest Solr can get into this situation. And there is a last check before becoming the actual leader and publishing his leadership is checking if no one else reported me as being faulty. So there is a special case as well when we don't see that we have problems, but others saw that we are disconnected, we didn't get something. And in that case, we shouldn't be the leader as well, but this is a special feature in Solr I'm going to discuss later. So what can cause recovery? There are routine events, like for example, if you create a new replica, then it's going to recover from the leader to get the latest data. And when you restart, it's also going to recover in case some of the updates were not received during the restart. And there are the less pleasant cases when the servers, the Solr is crashing, or the server goes down, or there can be network failures when the node gets disconnected from the Zookeeper, or there are very exotic cases when the leader is partitioned from the follower. Both of them are connected to Zookeeper. They are not aware of the problem, but they cannot talk to each other, and that can also trigger replication. So what happens during, sorry, not replication, recovery. So what happens during recovery? This is the simplest way to show it. This is what most of the talks are, how most of the talks explain the recovery. So first, when the node, the replica is recovering, it first publishes its state as down to Zookeeper. That is important because that's where you can notify all the other replicas and the clients that, guys, I'm having trouble, don't call me, don't send me queries, don't send me updates. I'm going to recover. Then it replays unfinished T logs, transaction logs, to have everything what he got earlier into the index. And it publishes its state to recovering, letting others know that, oh, I'm going to come up eventually and I'm going to participate as a working replica. Then it can do two things. The first, it doesn't necessarily wants to pull all the index from the leader. And for that, there is I think from the beginning of SolrCloud, we had the piercing, which is a simple way, like the recovering replica calls the leader that, hey, I have documents until 56. What's your latest document? He says the version is 97. Then the difference is, if the difference between his version and the leader's version is less than 100, which is the default number, but you can still configure that, then the leader will simply replay that missing documents, which is much faster, so the recovery can take pretty long if the index is huge and you have to pull the whole index files. But with the piercing, if there was just a little glitch, little disconnect from the Zookeeper and the leader didn't get too many updates, it's much faster to just replay those documents. If the difference is bigger than 100, we're going to pull the whole index. So basically, we can know that we have all the documents, and simply we go to an active state. So this is the high level. This is the well-known way how Solr recovers. And this incorporates a lot of problems. And the first question that can come up, that what happens with the updates during the replication? So if I start to pull an index of 20 gigabyte of data, the leader is going to have new updates, and he's not going to send it to me because I'm down or recovering. And how will I get those? Because when I go active, I'm already going to be behind, so I need to recover again and again and again. And if you have a lot of updates, you're never going to get into the consistent state. So if we're getting closer, we take a closer look, we can find that Solr solves it by buffering those updates. So what happens is that after replaying the log, it doesn't start the replication, the recovery right away. First, it publishes its recovering state and calls the leader that, hey, leader, I'm going to recover. Do you see me? Do you see me in the Zookeeper that I'm recovering? Because it's important that you start to send updates right now. Until you're not sending updates, I won't recover. So actually, there is a call to the leader, and it doesn't exit until the leader verifies that, yes, I see your state in Zookeeper, and I started to send all the updates to you. So from that point, the recovering replica can buffer all these updates and have that for later, and he can know that even if he replicated the index, he's going to have all the updates, what came in during that time. And when he finished the recovery, he's going to replay that buffer and eventually get into to a consistent state. Well, hopefully, if there are not too many updates, because if the updates are coming in faster than he can replay, then we're in trouble. This replay is only single-threaded, so it can be a bit faster, but most of the case, it catches up eventually. And after that, obviously, he can publish the active state. Now, this is already a much better and much cleaner way, but it's it was actually the way it worked before, but it was not enough. So what happened is that we just cannot ensure every time that all those updates in the past got in. So when we do the piercing, there is one problem with the piercing. We are saying that I have documents until this point, and I'm pretty sure that I have all the documents before. So if you have like 20 more documents, you need to send me only the 20 more documents. But there can be cases, unexpected cases, when actually the replica didn't get documents before. For example, we had a very annoying case when we saw that the replica had always less documents than the leader. And when we investigated, we found that the replication, the issue happens only when there were child documents and when there were updates during the insertion. So it turned out that when Solr replicates, there are cases that the updates are not going in an order. And Solr is very smart. Solr handles it and reorders these updates. But that part of the code that handled the reordering actually dropped child documents, ignored them. So when you had this reordering, and only when you had this reordering, and you had to have a really high traffic for that, on that case, some of the child documents or the updates of the child documents simply were ignored. And eventually, the replica got into an inconsistent state. So this was in active state. So after like 2 days, when the replica was recovering, he saw that I'm only missing 20 documents. He got the 20 documents and was still not in the consistent state. So it got into consistent state whenever it did a full index copy, which is relatively rare compared to the piercing. So what can we do with this? So Solr has the document in Lucid index, and each Lucid index has a version in the Solr indexes. And this version is unique. And so basically, if you know all the versions for the documents in your index, and you can compare that with another index, you can tell if the two index has the same documents. You cannot compare file size because the segmentation, how the file is split up can be different, but you can use this version number. So what we have here in Solr is called Fingerprint. So we are taking these versions, these unique versions, which are built up by the timestamp and the counter, and we create an accumulated checksum for the index. So we can always extend that fingerprint. We can rebuild it. I think the way it's built is we are taking a hash of the versions and we are adding them together. And what we have there is a number that is going to be unique for every index that has the same documents with the same versions, regardless of the segmentation or the file format. And what Solr does that before the piercing, it first asks to compare these fingerprints. If these fingerprints are matching with the leader, it means we don't even need to piercing because we are having the same index. Now, if we need the piercing, and the difference is only 20 documents, that after the piercing, we think they're going to have the same index. So we're going to compare the fingerprint again. And if we didn't have a missing document in the past, then this fingerprint going to match. But if we have some missing document for any reason that we are not aware of, then this fingerprint won't match. And we know that we cannot rely on piercing, and we're going to replicate the whole index. Copying the whole index eventually have the same fingerprint, so we don't need to worry about after that if we are having missing updates. So basically, Solr has this consistency safety net. So whenever a replica recovering, it can make sure, it can benefit from the fastness of piercing, but it also can be sure that after that, it's going to be consistent. And it's very fast because these fingerprints are calculated by segment. So after we have these fingerprints, it's relatively easy to calculate the next one. Okay, so we see how a replica can recover if it knows it has to recover. But I think I mentioned partitioning. And partitioning can cause a really interesting error. Just consider that the replica is connected to the zookeeper, the leader is connected to the zookeeper, but they are partitioned, meaning when there are updates to the leader, it starts to replicate it to the follower. And it's replicate, and there is the partitioning, and from that moment, it cannot access the replica. So we know already that the replica is, out of date. It has stale data, and shouldn't serve queries because it doesn't have all the updates. So the leader goes to the zookeeper and checks the state of the replica, and it sees it's active, and it cannot really do anything because it cannot access the replica. So what it does, it changes the state by itself. It overwrites its state in zookeeper and say that, okay, you're not active anymore, you're down. This is very important because right away he recognizes that the replica didn't get an update and knows that it has stale data. By setting this state to down, actually it notifies all the other replicas that might reach this unreachable replica that they shouldn't use it anymore. So how the queries are executed, if you send a query to one shard, it distributes the query to other shards, one of the replicas of other shard, and our stale replica shouldn't participate in this query because it doesn't have all the latest data. And also, if you're using SolrJ as a client, it also uses the cluster state, so you can also benefit from updating the state that the clients are not going to query this node, and you can somehow isolate this node that you cannot access. And after that, the leader is going to hammer the replicas with requesting recovery, so that whenever it comes back, either from network partitioning or from crash, it will know that it has to recover, and it's going to know that it has to take the data from the leader that he's missing. This sounds really good at NWest, but there is a tiny problem with that. The problem that this leader-initiated recovery can have a race condition with the regular recovery. So I mentioned that the leader doesn't know why the replica is not available. It could be partitioned or can be crashed, and it's going to restart and going to do the recovery. So in a certain unfortunate ordering of the events, the following can happen. The replica crashes, it restarts. The leader wants to send an update and couldn't reach the replica because it's not up yet. So it's going to go to the zookeeper and check its state. It's going to see in the zookeeper, in the cluster state JSON, that it's down. Or not cluster state, the state JSON, because it's changed. It's going to see that it's down. And it's going to see the node that it's up, it's connected to zookeeper. So it's going to assume it's partitioned. So meanwhile, the replica starts the recovery. So the first thing it does, as I mentioned, it publishes itself as down right after the leader checked its state and saw it active. And right away, it publishes this state as recovering. Now, the leader follows the leader-initiated recovery process, and seeing the replica unreachable but being active in zookeeper, it's going to change its state to down. Just right after the replica was setting its own state to recovering. Now, this is very important because, as I mentioned in the recovery process, the replica doesn't do the replication or the piercing unless it made sure that the leader sees its recovering state in zookeeper and starts to send the updates. So, excuse me? Is this where you get the error overseer says we're the leader, but we don't think so? No, I don't think so. It's a different case. So what happens is that the replica dials into the leader and says, I'm recovering. Do you see my state? Please, when you see my recovering state, start to send me those updates. Yeah, but the leader just changed his state to down from recovering, and in a different thread, of course, so he's not aware that he himself messed up the process, and the replica is going to wait until it times out. I think it's 3 minutes until it times out, waiting for the leader. So this is going to work itself out because in the next iteration, it eventually will be able to set itself to recovering and wait the leader to send the updates. But it can be very painful if your cluster is mission critical and you don't want these 3 minutes to happen. So my job has a patch for this. I think it's really good state and hopefully going to be merged soon, but which going to solve this with event-driven solution through Zookeeper, and that is actually going to solve the problem what we have here, that if the replica is partitioned and we are hammering him with the request to recover, we cannot still really ensure that no one will hit the replica with the stale data with any query. So if it's really partitioned and some client can access it and he's not watching the Zookeeper for the downstate, he is still going to query the replica with the stale data. That can be sometimes hurtful. Yes. There is one more interesting feature that Solr can do to help your, well, in this case, more like the availability and the way how it can react for problems. So assuming that you are using a shared file system like HDFS to store your index, you have a good property of your architecture that each node can access the same folders and the same indexes, meaning that it's not really important which node is actually accessing an index. It doesn't need to be on that instance. So we have a feature in Solr that you can turn on by collection, I think, on a cluster as well, that enables Solr to do a special error handling if a node goes down. So in Solr, there is one dedicated job that you only have one in a cluster called overseer, and overseer responsible for managing the cluster, setting up new cores, and well, in this case, getting this error when the node goes down. So if the collection has this auto-add replica option on and a node goes down, this overseer going to see that the error, and after a short timeout waiting to that node to recover, it's going to create the same core on a different node and going to tell that node to use the same folder on the shared file system that the previous crashed node used. So that way you can bring up a node really fast without the need of copying all the data, because if you would add manually a new replica to the shard to resolve this issue, that you're going to face with the delay of the replication of the whole index files. So you don't need to do that in case, and especially because Solr is going to automatically do the whole thing. And this actually makes it possible to have only one replica and still have the availability, not high availability, but the availability, because you have the durability from HDFS. So your index is going to be replicated already through HDFS. So you don't need to worry about losing data from one single node's crash. And if you don't need that high availability or that performance that the replication, the multiple replicas would give you, then you can use only one replicas and leave it to the overseer to manage the moving of that core if it goes down. And you have the index on HDFS, so you can have that core on any node of your cluster. And also, if one of your machine permanently dies, I don't know, hardware failure, and you have to replace it, you don't need to manually move all the cores by yourself, because overseer are going to move all the cores. Just think about if you don't use this feature, and one node goes down which has, I don't know, 6 replicas of different shards, then those shards are going to have one replica less unless you add those replicas back on different nodes. So this feature sounds very exciting, was not so reliable. There were a lot of fixes lately by Mark Miller that made it more stable and more reliable, but still it's under rewrite under this GRID that also changes it to a more event-driven way, incorporating our auto-scaling APIs and events. So eventually that's going to be more reliable and more robust. I think this is what I had for today. So if you have questions about the slides, I would be happy to answer those. Yes?
So on the still connect to the same index, or will the index be completely lost?
So you're asking if all the, without all the replica, if all the nodes are going to go down?
Three replication factors.
Yes.
All the three instances of one.
Yes.
And then when we bring up a new instance, will it still connect to the same HDFS and use the same directory, same index?
Will that recover? So the question was that if I had 3 replicas on 3 different nodes and all the 3 nodes goes down and I start up a new node, will it put it back? So my assumption that the overseer will come up in the new nodes because obviously you lost overseer as well, and it's going to see that none of the replicas are there, and it's going to find a new place in an active node for those replicas and going to spin those up from the same file system. Yes. Yes, unless you use Zookeeper, because Zookeeper has the information about the shards and the replicas and the folders, the paths of the cores. Yes?
What happens if a update fails and the leader wants to publish the replica into leader-initiated recovery, but then the leader fails before it updates the Zookeeper state, and the replica comes back before that? What's the leader election process like?
Yeah, well, if you're assuming we have 2 replicas here, in this case. So I mentioned in the beginning that in the leader initiation, leader preparation process, the replicas are trying to check if they could be the latest. So in your case, if the leader gets an update, tries to replicate, and crashes before it updates the Zookeeper state of the replica, then you might lose that update unless that leader comes back in time, and then it's going to replicate those updates to the new leader. That can happen. And I cannot really answer what is the order here, but it gets into the transaction log after it wrote it to the index. So assuming that the leader dies at that moment, it not necessarily have that update ready and done.
Will the replicas negotiate based on latest version to see who's the best?
Only if a leader crashes, it doesn't wait 3 minutes to the other replicas to participate. So assuming that the leader won't come back, it doesn't want to hold back. So a new leader is going to be elected, and they are going to negotiate between each other. So if you had multiple replicas and one of them get this update, he's going to send this update to the new leader. In that case, you have the documents. But if you have 2 replicas, then it's less likely because the leader went down and it had the updates. And yeah, this is a good reason why you should have more replicas than 2. Yes?
I'm a little confused when you talk about the replica partitioning thing. Exactly what you mean, what happens there?
Okay, so the question is what replica partitioning means. Well, if you look at the CAP theorem, you have to prepare for your network to have a split brain, which means that you have a lot of nodes, and you could draw a line where it's a very simplified way to say, but those nodes cannot reach each other. Both of them are going, both of them can communicate with each other, but they cannot. So a special case can happen when the leader can access Zookeeper, so it's connected, he sees he's connected, and everything is fine for him. And the follower is connected, but they cannot talk to each other because they are partitioned. There is some routing issue configuration in the routing. It sometimes happens. Domain resolution doesn't work correctly. And on that cases, when the leader tries to replicate to the follower, it simply cannot access it through the network. But it can access anything else, and anybody else can access that follower, and they can both connect to the Zookeeper. And in that special case, you have the partitioning. Yes?
So if a leader goes down and you start doing through the recovery process, would it make any difference if you could pause updates and writes into the system during the time when it's recovering, or does that make much of a difference?
So the question is that if the leader goes down, will it help to pause updates? Well, you wouldn't be able to do updates for that shard. So those shards, the updates to those shards are going to fail anyway because you don't have a leader to write to. So posing them, you would need to pose them, but actually you don't need to. So for example, if you have a multi-tenant installation where the shard key, the routing key to place the documents is not based on the document ID, but based on the, I don't know, the account ID, then you would not necessarily post the updates because other tenants can work on the different shards.
But what you got to do with leader and the other nodes are in recovery, does that make
Well, if you have the new leader, you can you already send in data. You don't need to pause. This is going to work out. So if you have a heavy load and the new leader gets elected and gets active, you can still have your application running. Yes?
Within Zookeeper, is overseer queue used to orchestrate, like I know there's overseer queue failure, there's overseer queue work or work queue. Are these used to orchestrate all the replication segments and things? What hasn't been, or what hasn't been synchronized, and does that play a part during these leader elections?
Okay, the question is that overseer work queue is used in this recovery. No, not really. The only part where it gets used is when publishing the new states. Okay. So nobody writes the JSON files in Zookeeper, but the overseer. So what you do that when you publish it, it's an asynchronous call, putting it to the queue and publishing it. It is actually very important in this case because if the overseer is overloaded, for example, you have way too big cluster or way too many collections in the cluster, then the overseer can be slowing down and can be way behind in his queue. And if you want to publish recovering state, the reason why the replica needs to wait until the leader sees that recovering state is because it has to go through the overseer. So the overseer updates and the leader gets a notification through the watches. Yes?
Would we be able to alleviate these problems with Solar 7 where we have the pull from the master slave?
Yes. Okay, I didn't mention in my slides, I had an asterisk for that. So the question was that can we eliminate these problems with the new replica types in Solar 7? I don't really want to talk about those replica types in details because we have two other talk for that. But there are new replica types, and the thing is just from the three replica types that we're going to have, only two can participate in leader election that has transaction log, and one is just pulling the index all the time. So on that case, the recovery is simplified because when it recovers, it just pulls the index, so there is no piercing. But it cannot really participate in the leader election. So one of the talk is about something of master slave, and that's going to elaborate on that, why it really won't change the way how the recovery works with the old replica types. If there is no question, one question.
Some situations we notice that Solar node is continuously switching between active and recovering state continuously. So during that time, we go to Zookeeper. Zookeeper says for a given state.json, we know what is the last modified time. But is there a way we can see the history of state.json? When was it active for a particular node, when it changed to recovery?
Yeah. So the question is that in some cases when the replica's state is continuously changing, we only see the current state, and is there a way to see the history? Yeah, it's a very good question. We were thinking about implementing some change log. The only way you can see that is by checking the log, because every cluster change is getting distributed and getting logged, I think, at least into the log of the current Zookeeper. But for that, you need to know which one was the Zookeeper at that time, and you need to log in, see the log inside that instance. It is very painful to see the history because you need to scroll through a million lines of log file on several instances. But currently, I'm not aware of a better solution than that. Okay, that's a question. That's actually a very good idea to look at the Zookeeper transaction log. I haven't done that yet. Yes, I think we have one more question.
Checksum that we talked about.
Fingerprint, yes.
Fingerprint. So that fingerprint calculation does take into account any fields in the documents, or is there any specific mechanism to calculate that checksum?
Sorry, could you?
So there's some calculation.
Yes.
So does it take into account any specific fields in your Solr documents?
No, only the version. So we assume that if you have so the question was that during the checksum calculation, does the content, the payload of the update has any effect on the checksum? And actually, it's not a hash of the document. It's just a hash of the version. We assume that if we have that specific update with the specific version, we have it all. Probably because the underlying layers already have these checksum for the data, the TCP protocol, and we only need the version. So if we have that version, we are going to have the same payload.
Actually, application was like I was thinking in perspective of like a disaster recovery. So if you have two different clusters that you are indexing, can this be used, to understand whether one of the clusters is lagging behind because now you know the checksums, right?
Yeah, well, you can use it, but since these version IDs are issued by the leader, and each shard has one leader, and that leader has a unique set of versions. These versions are unique just among the replicas of that shard. So you cannot really rely on even between the shards that they have anything to do with each other. Yes.
So the piercing is set for 100 documents.
By default.
Side effects or consequences of increasing that number?
Yes. The question is that is there a side effect of a consequence increasing the piercings 100 documents? So I asked Yannick about that, and Yannick said that we don't want to increase that because we might have really large, multiple megabytes of documents, and the piercing documents are sent not in a stream way. So these are big requests, and they're in memory, and setting it to a much higher setting would risk out of memory exception, and this is actually the practical reason behind that. I think I'm out of time, so thank you very much, everybody, to attend the